All right, ladies and gentlemen, for our forces test coming up, we have a lot to review. This video will be going over Newton's laws of motion. Let me take you through this PowerPoint. This is available through Google Slides, but I want to emphasize a few things and cut out of some of the slides as well, just to kind of streamline this process for you. For the upcoming test, you have to be aware of Newton's three laws of motion. They are here as the first law, or law of inertia, the second law, F equals ma, and the third law as action-reaction. We went over these in class. Here they are kind of reworded, and we're really looking for you, aside from the second law, which requires an equation. We'll make a separate video for that. We need you to understand how these apply to objects as they move. So the very first law we spent quite a bit of time on. This one simply states if something's moving, it's going to stay moving. And if something is at rest, it's going to stay at rest forever, right? Unless some other force acts on it that causes it to stop or causes it to go. Okay? The second law just gives us the connection between force, mass, and acceleration. We'll show you that equation in just a second. And then the very last one is action-reaction. For every action, for every event, there is some equal and opposite reaction, and we sometimes forget about the reaction. So sitting on a chair, you're pushing on the chair has to be pushing on you, with an equal force and in an opposite direction. Okay? So real quick, let's take a look at inertia. The first law, sometimes called the law of inertia, is this idea that objects like these pumpkins are going to stay put. They're not going to move. Inertia is something that resists the change in whatever the current velocity is. So a really big pumpkin with a lot of mass is not going to move easily. It's going to take a lot of force to get it moving. But once it's moving, it's going to take a lot of force to get it to stop moving. That's the idea. Inertia is indirectly connected to mass. So if you have something with a very small mass, let's see if we can find something like this golf ball here. The golf ball is not going to be very difficult to get moving, but it does require some force to make it move. Once it's moving, it's not really hard to stop a golf ball. Over time, it's going to go ahead and stop itself just from friction. All right? So that's the first law. Remember, there are four kinds of friction that we want you to know about. They're listed right here. Sliding friction, rolling friction, fluid friction, which we sometimes call air resistance, but take a look, it's also liquids, right? Fluids are gases and liquids. And then static friction, this idea that it's difficult to get something moving. As soon as it's moving, there's no static friction anymore. It's just that resistance to get moving in the first place. Okay, so remember, static friction is only for an object that is not moving. Now, the second law is this connection between force, mass, and acceleration. Okay, the way it's written, mass multiplied by acceleration equals the force, but this can be rearranged to solve for either mass or acceleration. Okay, on your test, you'll be given this equation, and it will be manipulated for you so that you'll have it solving for force, you'll have it rearranged to solve for mass and also for acceleration. All right, so an example of this would be like this question here. How much force is needed if you want an object to accelerate, and that object is a 1,400 kilogram car? And how much do you want the acceleration to be? Here they ask for 2 meters per second. So the formula as written is ready to solve for force. We just have to plug in mass. There's our mass in kilograms, and our acceleration in 2 meters per second squared, or per second per second. And when you multiply those together, we get 2,800 kilograms meters per second squared. Remember, that is also what we consider to be a Newton, because we're solving for force right here. Okay, so the second law is just a 3-variable equation that you'll be asked to solve for either force, mass, or acceleration. Skipping over to action-reaction. Okay, this one's my personal favorite. Action-reaction is this idea that if you can identify a force acting on an object, there's got to be some equal and opposite force there. So we mentioned the chair earlier, and here's another example. So when you sit in the chair, your body is being pulled down by gravity, and so you are pushing on that chair. But the chair has to push up on you with an equal and opposite force. If it's not equal and in an opposite direction, then you would be accelerating, either up if the chair is pushing more on you, or down if it is not. Okay? Let's find another good example. So fish. If a fish pushes with its fins on water backwards, the water has to push forward on the fish, and that's what causes them to be propelled forward, right? Birds as well. If a bird uses its wings to push down on air, then the air has to push up on the wings in order to get the bird to stay in flight. Okay? So be familiar with those three laws, just basically what they say and how they apply to motion.